Okay, so what we're going to do is review the algebraic representations.
Are you writing it?
Yes, you are. Of transformations. So we're going to write down all the information. Now, when we do algebraic representations, that means we're not going to be putting numbers in. We're just going to use the variables to represent the coordinates of the ordered pairs. Okay? So, Kenny, you got this? So let's start with translations. So I'm going to do it a little differently than your book had it in the lesson, where the translation is dependent upon what they tell you. Sometimes they have you translate on the x's, sometimes just on the y's, sometimes on both, sometimes you're going up, sometimes down, sometimes right, sometimes left. So there's all sorts of combinations. So the generic would be this. Here's your ordered pair. For a translation, you can add or subtract a value, and they call it A, to the X, and you can add or subtract a value to the B. So I'm going to go over the add or subtract bit and what does it actually mean. Okay. Now, if B is 0 or A is 0, that means you're actually not making a translation. Faith, you're supposed to be writing this down, please. Okay. What I don't get to do when I finish what I'm supposed to do is talk to people waiting for the next thing to be written down. Thank you. So, if you have a positive A, what direction does it tell you to move your shape? Right. It tells you to move it right. So you're going to move right A places. And again, A represents some number. If it says minus A, what direction are you moving? Left. So the sign and the number we have to look at both of them. And again, A, and I'll put A in quotations. Places. Okay? If you have a positive B, what direction are you moving? Okay, you're going to move up B places. And if you have a negative B, how are you going to move? If you have a negative B, you're going to move down. B places. So sometimes they just make you do one. Sometimes they make you do both. Okay? So those are translations. So again, you'll see numbers written in there. And when you are giving me the answer, if somebody says name the transformation, you can't just...
Please excuse this interruption.
The next transformation is a reflection. And we have two different possible reflections. Actually, there's more than two, but the two that we're going to focus in on. All right, so the two type of reflections that we're focusing in on is one that's over the x-axis, would be the first one. And the best way to remember what to do on this one is look at if I'm reflecting over the x-axis, the x isn't going to change. It's the y that's going to change. So we just have a sign change on our y's. Kenny, you need to write this, buddy. The other one is over the y-axis. So again, I would take my original ordered pair, and this time I'm going to have to change the x, and I'm going to keep the y. And again, if you just take a picture, and you're looking at, here's my shape, and I'm going to reflect it over the x-axis, you're going to be in a new y value. And so that kind of goes with this picture, and then if we do one here, and we're going to go over the y-axis, we're going to go over here, so it makes sense that the x's now have changed signs. It'll come back. Okay? So then the next one is the rotations, and that's the one that really I think these algebraic representations help the best. And there's only 3 rotations that you guys actually need to focus in on. So with rotations, there is a 90-degree clockwise. Now that actually does describe a second rotation. What other rotation would have the same exact change as the 90 degrees clockwise? Kaleo?
270 degrees counterclockwise.
It's what adds up to give me to 360, and it's going to be the opposite direction. So it would be counterclockwise. Okay. So your x, y, and again, if I draw a picture real quickly of this, and we're here, and we're going to rotate clockwise, okay, notice the sign that's going to change. Your y went from being a positive one to a negative one. So we're going to end up changing, make sure I get this right. We are going to swap spots with the x and the y. And on this one, if we're going 90 degrees clockwise, because we're swapping spots, we are going to change the sign of the x. Okay, so when we have that rotation, the x is actually going to have to change its sign. There was an example of homework that you guys did, and most of you had the wrong starting point for your triangle when you did your rotation. And so even though it looked good, it actually was wrong because of not swapping the sign properly. Then we also have a 90 degrees counterclockwise. Which is the same as what other rotation? 270 clockwise. We're not going to whistle in class, thank you. And you're supposed to be taking notes, not scribbling on the spiral I gave you. We're still going to swap the x and the y, but we're going to make sure that we change the y's value to its negative first. Okay? The last one is the 180, and notice that the 180 does not get a clockwise or counterclockwise because we end up in the same exact position both ways. So we just say it's a 180. And what's nice about it is that the x and the y don't swap spots. What they do is they change signs. So for me, memorizing those 3 in particular are the most helpful. The others I can logically kind of figure out, but this one, it's going to make sense if I deal with the change in my values. And then the last one is the dilation. And we're going to use K to represent the dilation amount for both of them, but I'm going to give you a specific about what that K is going to look like. So the 2 different ones, the first one would be a reduction. And when I multiply by this K value, it's going to shrink my original picture. So what numbers did we say I would need to multiply by in order to shrink an original shape? What kind of numbers? Do you remember? Not less than 0, that would be negative. Okay, it's got to be somewhere from 0 to 1. So if my K value is greater than 0 but less than 1, so in other words, a fraction, that's going to give me a reduction. So again, the 2 algebraic representations for reductions and enlargements are exactly the same. I'm multiplying by whatever that scale factor is. The scale factor, however, is represented different ways if it's a reduction versus an enlargement. So an enlargement means that my image has to be larger than what I started with. So what kind of k values am I going to need for this? What do we say it had to be? What did they have to look like? I'm sorry? They have to be greater than 1. And again, the representations would be the same. So what's different between these is not what the representation looks like, but what kind of number is your scale factor. So k just represents the scale factor. When your scale factor is a fraction, you're going to get a reduction. When your scale factor is greater than 1, you're going to get an enlargement. Okay?